This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 98, we delve into the capabilities in Ansys for simulating hypersonics, talk about the upcoming Level Up 2.0 technical conference, and take a brief look at news and events. I want to welcome you to our 98th episode of our little podcast. My name's Eric Miller, and I'm one of the owners of PADT and your host. It's hard to believe just a few more, and we'll be at episode 100. I want to thank everyone for coming along with us on this audio journey. And October is here. I'm recording this on Sunday evening, which is October 3rd. Took me a while to figure that out. So it's October 3rd. I'm recording this on a Sunday night here in my office at home. And at least here in the U.S., we're really trying to find the right way to get out and to engage in business and personal activities and still keep safe and keep the spread of the virus down. I personally went to San Diego for a wedding last weekend. It was the first time I was around most of my family in over 2 years, and it was good. And San Diego is always a great place to visit because the weather's wonderful. You can be outside all the time. But it was still strange. And I, for one, like I said, even though the whole ceremony and everything and the reception and all that stuff was outside, it was a nervous time for me. I'm still not adjusted to being around people like that, even with masks and distancing and outside and everything. Right after that, I attended a technical conference earlier this week in Boulder at the University of Colorado. It's the AIAA Rocky Mountain Technical Symposium. It was a fantastic event. I really, really enjoyed it. It was very well run. It was great mask adherence and big spaces so we could spread out in the rooms. I was able to also spend a day working out of the PADT office in Littleton, Colorado. And that felt really good as well, to be there. It's been a while. And didn't do too much interaction because everybody's really busy, but see a couple of the employees that work out of that office as well and prep it for a new employee that's joining PADT in a week. So that was really great to do, meet a new employee that actually I'd only met virtually through all of this, that's working in our Colorado office as well, one of our high-frequency electromagnetics experts. So it was really great to see. I hope you and yours are staying safe while also finding a way to spread your wings a bit more as well. October is shaping up to be a very busy month for both in-person and virtual events. In fact, we're going to skip the news and blog part of the podcast this week to include a short interview with some folks at Ansys about the Level Up 2.0 virtual conferences that's coming up. But first, I want to do our main interview. And this is a topic that we have experienced massive interest in over the past 2 years or so, and it's hypersonics. In fact, this interview prepped me for the session on hypersonics at that AIAA Rocky Mountain Symposium I went to. They had a whole session on it, and I actually understood the concerns and the issues that they were dealing with because of what I learned from this interview. So it was very useful and really came in handy. And I think that, as you'll see, it's going to be around for a little while. So we should all learn a little bit more about what we can do in the Ansys world with hypersonics. So let's find out from the experts. I want to welcome everybody today to a topic that we've been ironically, or I don't know if it's ironically, talking about a lot lately, which is hypersonics. It seems to be coming up in a lot of different conversations. And fortunately, we've seen some fantastic improvements in the Ansys product family, especially in Ansys Fluent, around hypersonics. So we thought this would be a great opportunity to get people who actually know what's going on in Ansys with the hypersonic tools and talk to us about it and answer some questions. So I've got Bruce Crawford and Valerio Viti here with me today. Welcome, guys.
Yeah, thanks for having us.
How you doing, Eric?
Doing very good. So I'm going to actually start with Bruce and ask you to kind of introduce yourself, what you do for Ansys, and your journey to doing simulation. Where you worked before and all that stuff.
Okay. Well, again, my name is Bruce Crawford. I've been with Ansys for the last 10 years. Currently a senior application engineer. Subject matter in combustion or high-speed, reacting flows. Been doing this for a little over 25 years, working, aerothermal problems, high-speed flows, combustion. I've done work, with different government entities and other software companies, but, specializing it in high explosives and TBX type explosive stuff and trying to model that stuff on a computer. That's what I did in my previous job. Trying to predict the IR signatures for that. That's kind of a niche I had. But
fun.
Also doing scramjets and other turbo machinery on top of that. But it's been a fun, say it's a lifetime. Over 25 years of doing it now. So
that's great. That's great. It's an exciting area. How about yourself, Valerio?
Well, after listening to Bruce for 25 years, I feel like I'm out of school. But I'm working very closely with Bruce, and it's always good because we are learning from each other. I've been with Ansys now for 15 years, and right now I'm leading the aerospace and defense team on the application side. And the journey that brought me over here was just doing grad studies, a PhD at Virginia Tech, and doing experimental work in high speed flows and turbulent flows, shock boundary layer interactions, supersonic injections. And I found out that CFD could do a lot of the stuff that experimentally we could not see or measure. And so one thing led to the other, postdoc, and then I've been working out for Ansys, as I say, for 15 years, wearing multiple hats, but my most recent is with aerospace and defense.
Cool. Well, we really appreciate you guys coming on and helping us understand, because I think your statement about helping each other learn is a great one. Our experience so far with this area of hypersonics is we're all learning together as we move into this new level of it. One of our employees, I don't know if you guys have ever worked with Tom Chadwick, he actually worked on one of the aerospace plane projects that NASA had in the 1990s, and so he's got a little bit of background in scramjet simulation in CFD, but it couldn't really do it back then. And so we're really excited. He's especially excited to see all the new stuff that we can do with this. Why don't we start with, for those that aren't super familiar, don't really know the difference between, supersonic, transonic, and hypersonic. What is hypersonics, and why is it unique from a simulation standpoint? You guys can take that one.
Yeah. Okay. Well, with hypersonics, it's normally anything over Mach 5 that we're trying to deal with. It starts where you start getting the chemistry, air chemistry starts getting involved, and other things. But it's anything above Mach 5 is called hypersonics. Anything below that, is our supersonic regime. So. That's a good point. Yeah, I never thought about it that way, but it actually makes it very simple. It's a high enough compression, right? The shock waves are compressing the air enough to where chemical reactions start taking place, right? Yeah. You start getting the temperatures and everything. Really get into that area where materials really come into play. But Valerio, before I can get better detail if you want to.
Anything you want to add to that? Yeah.
Yeah, Bruce gave a very good explanation. I think, the tricky part that when we are dealing with hypersonics is that as compared to supersonic, in which Mach 1, that's like a sharp line. And sure enough, you can go into the details and look at transonic and the part of that supersonic flow. But it's a clear definition, that Mach 1. With hypersonics, the Mach 5, sure, it depends. And also Mach number starts losing a little bit of significance once we start looking at high enthalpy flows. But that is the Mach 5 that commonly agreed upon by the community, arbitrary line where we say, okay, we go in hypersonics. But really, sometimes we've been looking at cases of Mach 6 in which chemistry is not playing a role, and the community calls them hypersonics, but really just a high supersonic. Okay. So a little bit of a gray area.
Good. So this idea of the shock wave really is key. Are there other aspects of flow that are different when you're in this hypersonic range as well? I mean, does it, like what we were discussing with a customer earlier, that boundary layers just don't quite work the same, right, when you're at these kind of speeds?
It varies based on what speed you're at. I mean, and what type of flow. If you're doing just in atmosphere flying, it's going to be a little different than re-entry flow, which you started coming in at a high Mach at the beginning, where you the boundary layer, again, it's got to be laminar, and dealing with all the thermal stuff, how do we deal with that? The chemistry, where we have the ionization coming with reentry, it's really, causes havoc with anything else going on in that system that we would have. But, there's a lot of, as soon as you get to where the temperatures gets above 4,000 degrees, that's when everything starts getting a little hectic, with the systems. So
yeah, definitely. So that's another good thing to cover before we get into the details about Fluent. Is this is used for hypersonic propulsion, for hypersonic, say, missiles or aircraft for external flow, but also reentry, correct? And are there other areas that where we see hypersonic flow?
No, I think you covered all of the applications. Yeah, and for the reentry, it could be Earth atmosphere, or it could be interplanetary or other planets atmospheres like Mars.
Good point. Yeah, so different pressures, different chemistry. Yeah. Wow. So it really is multi-physics on a grand scale. You've got a lot going on in there. Yeah. Okay, so let's talk a little bit about the Fluent product. So there's always been some capability in this area, but I don't know. We'll start with Bruce. Why don't you go over what's been kind of added in the last couple of years, maybe 2 to 3 years, that have really increased, or we're seeing our users use it more?
Well, I mean, in the last couple of years is when we've really been pushing the capabilities of Fluent with the density-based code, which kind of was what we would like to use for a lot of these cases because of the Mach number we're dealing with. So we can deal with the shocks. Everything's coupled. But the issue is we were always having convergence issues with DBNS code. There's been a lot of work and really digging it, because technically it wasn't touched for almost 15 years since it was built. But now with the new team put onto it, going through, checking, making sure the matrix is all there, the robustness of the DBNS code just to solve, ideal cases, gone up significantly. Just taking stuff that would take 30,000 iterations down to 500 iterations.
That's
to
big.
solve.
Yeah.
That's and it converges so much smoother too. It just drops like a hammer. Being said, that's getting the basis for that was key, and that helped. It was a few years ago when they got that started. Now adding on to that, trying to add all the different capabilities. And when we get into these flows, what do you have? You have your just basic flow. You have your air chemistry. So we had to deal. How do we deal with air chemistry? We had the old NASA capability, with the thermal data, with the old NASA 7 coefficient model, but its temperature limitation is around 6,000 degrees with that thermal model. So the first thing we did was take care of putting the capability reading the latest and the newest implementation of the thermal data from NASA with the 9 coefficient model, which takes us up to 30,000 degrees.
Wow.
With thermal. So that was the main goal. We had to have that first to be able to handle that, to make everything work. And then once we started that, we started looking at the different reactions capability there. And then we found bugs as we went, dealing with ions, dealing with that, fixing that as we go. And we really, got that working really good. And also they found issues dealing with species with it. Once we fixed, the main code, then we started adding in dealing with species and found issues dealing with Jacobians and stuff like that. And once we fixed that, everything just started falling into place. So, we could do ions. We could actually take that into the other codes and calculate the different electromagnetics. And then going from there is, the meshing helped out a lot with these cases too, improving the meshes and making sure we could, do different things. But most of it was trying, from my point of view, with reacting flow, was trying to get the reactions right, because then, we're going to get the chemical non-equilibrium properly calculated for the flows. As you get up into the higher temperature range too, we added other models like the 2-temperature model capabilities, so we could have to deal with the vibration or rotation of the different species. So, because as you get higher, you'll have those different modes, and they do affect the flow and how things react. That's been the latest thing that's been put in the latest code, and we actually can do with have thermal non-equilibrium and chemical non-equilibrium at the same time, which is a nice, feature, because a lot of the NASA codes have that. It's not really out there for a lot of other codes.
Okay.
So,
in a commercial.
If I'm wrong, Valerio, tell me if I'm wrong on that.
No, you are right. You are very right, Bruce. What I would say about Fluent is that it is a one CFD code, but under the hood, it really has two separate flow solvers, as Bruce was pointing out. And one is what is called the pressure-based solver, and it's called that way because of the solution strategy that it's using. It's just a family of CFD solvers that, is not only us calling it that way, just community. And in pressure-based solvers, typically they are used for lower speed flows, even though, we've been keep pushing the envelope. We've been running cases at Mach 6 and 7 with the pressure-based solver. But yeah, Bruce is 100% right. The other code, the density-based solver or a high-speed solver, is what we are focusing on when we're looking at hypersonic flows. And there's been a tremendous amount of work put into it in basically improving the performance. 2 buckets. I usually consider it, in reality, 3 buckets. But and the first one is numerics, basically improving robustness. What uses a code if you have everything set up and it doesn't converge? It's useless. So that's the first bucket that we've been addressing, basically dealing with those extremely steep pressure gradients and tight coupling between momentum, continuity, and energy. And we're still working. That's continuous progress, but there's been a lot of improvements. The other bucket is physics. How do we add the necessary physics? And really the only physics that was not at that point built in, the major one, was the thermodynamic non-equilibrium, and right now it's built in. We've been able to do it for many years using UDFs, but now it's all built in. And the third bucket, it is usability and basically workflows, and how do we make the solution of these complex problems more approachable to everybody. And that is the third bucket, and I'm talking about pre-processing, cleanup of the geometries, pre-processing, so the meshing aspect, and then the setup of the problem. And that is a big topic, not only for hypersonics, but for all of our tools. It's usability and productivity, engineering productivity.
Good. Yeah, and that's a good point. Across all the products, it's been really important to get people access to these tools that really only existed in government labs for such a long time, and getting them out there. One thing that Bruce brought up that I thought is really important is you kind of mentioned meshing along the way, and I think it's a great example of how there's a lot of moving parts to getting a new capability or improved capability like this one, and a lot of work has gone into fluent meshing over the last 10 years. And I think it's another example of enabling some pretty sophisticated. Either you want to talk about how meshing interacts with the tool. Is it adaptive, and does it refine around where the shock waves are? Does it do that sort of stuff yet?
Yeah, we do have that capability, and it's actually been well tested for the external aerodynamics for these hypersonic flows. Good. And it actually really makes it easier and keeps the mesh reasonable, when you're doing it. So it has different methods, and actually it's gotten very robust in the last version and being able to do this stuff. And it does it with the different mesh capabilities that we have with polyhex core, poly, and TED, as we had previously. Now, we're still in the process of testing that with the combustion side of supersonic combustion, but it's showing promise, and it's working pretty well. But we're making sure that we're resolving everywhere we need for that, because instead of just having the shock wave as we do just external aero, we have the shock and the combustion,
Right.
density going on in the same area. So we have to make sure we have enough gradient resolution there to make sure we're picking up all the processes. So,
Yeah.
and it's there. It's, very user friendly from before. It has its own panels. It's actually real easy to set up now, from previous versions, but it's being very well tested. It's being exercised a lot and being tuned, and so we have, coming out of the box, you just turn it on and it should work for 90% of the cases. And that's what I'm hoping, we get a little higher than that too. And hopefully get that way with the combustion cases for these high speed flows and reacting if we need it. Okay. That's
Cool. Yeah, no, that's a lot though. I mean, I think if you really sit down and think about what went into figuring out where to have localized refinement and where not to, it's there's just a lot of moving parts going on in creating a simulation for this type of event.
And Eric, I want to add something, because its adaptation has been available in the community for many years, obviously, and as well in Fluent, we've had adaptation based on, for example, flow variables, or their gradients, or their curvature for many years. Things get a little bit more tricky as we keep adding, for example, different mesh topologies. And, the most recent one is a polyhex core, or if you look back at a few years back, also the polyhedral mesh type. And each mesh topology has slightly different behavior once you start adapting it. And so that is, one thing is identifying where we need to adapt, and that is, work in progress. We have all the parameters that I mentioned. We're actually adding automatic mesh refinement using, for example, a Hessian approach, so an error-based approach, and that will be very powerful. But then the other topic is, how do we refine the mesh? Now that we know where we want to refine it, is like, how do we refine it? And that is, we have different types. Again, they are under the hood. There's isotropic, which has been the default. There's anisotropic adaptation for example, boundary layers. And we are adding volumetric anisotropic, which is more like not only adding cells, but also squeezing the cells, or moving the cells where we need them without actually having to remesh. So it's a combination of approaches that makes it very powerful.
Very powerful. Yeah. I think back to some of the early codes I remember seeing out of NASA that were basically an octree, right? And they would just divide the elements up, and that we've come a long way for that. Cool. What about, and I know this is a tough one because a lot of what's done with Hypersonics isn't publicly available, but can either of you talk about any examples of people using Ansys Fluent for hypersonic simulation and share that story?
Bruce, maybe I can take it, and I don't know how much we can talk in a public domain, but an interesting thing that we have going on are a few partnerships that we started with universities.
Good.
And I will start with the University of Texas at Arlington, and Professor Maddalena, he's developed his design. Basically, his lab has the only ArcJet facility at a university in North America. So very unique facility. And I believe right now it's the only one out of 3 in North America. The other ones being NASA, Ames, and AEDC. So very, very unique facility. And we have this partnership in which basically they're using our tools to design the experiments. And these are all like hypersonic conditions, and to analyze the flow field. We have another partnership with Missouri Science and Technology Rolla, Professor Serhat Hosder, and he's basically been looking at uncertainty quantification specifically for hypersonic flow fields. And that is work in progress. We enter actually the NASA High Fidelity CFD workshop with Professor Hoster and one of his students. And this is all, as I say, ongoing work, and it's very exciting actually to see even students getting involved and learning how to solve these complex problems using our tools.
Yeah. Also, from the combustion side, we have some work going with Virginia Tech, doing some rotating detonation engine, which is supersonic combustion, trying to help them. They got a grant from the DOE to research it to see how applicable it is for land-based power generation.
Oh,
so,
wow. Okay.
So that's out there for that, and there's other universities we're working with on that too, to work on RDEs also with them.
And there are lots of commercial and military applications, but we can't really talk about any of those. So I'm glad you brought up the military education.
There's a lot of publications out there. It's a lot of work has been done by national labs and by the different entities that have interest in it. So it's in the last 5 years, it's gained speed. In the last year, it's really gone up exponentially. So.
Yeah, right. In fact, our discussion started because I'm trying to work with the university. Here at PADT, we're trying to work with the University of Arizona, which are building a hypersonic wind tunnel right now, and it's pretty exciting to see that going up. And hopefully it'll get used to come up with some new technologies and some new breakthroughs and correlate some of the models that we're doing. Yeah, so I've got some examples I could talk about too, like the call I just got off of. Ironically, they were both scheduled, the two hypersonics discussions scheduled one after the other, but I can't. So those of you who are listening, Google and see what's publicly available. But there's a lot going on in hypersonics. Anything you guys want to cover that you think our listeners should know about the tools?
I mean, getting into it, how do we get to the hypersonic speeds? A lot of things, either just scramjet engines, but how do you get those up to speed to get them to light? Right. Well, modeling that stuff, we have to, they have used rockets, what kind of rockets do you want to use to get them up to speed? They have that capability when they do tests. And we've been adding a lot of capabilities trying to model solid rocket motors.
Okay.
We've been working with one customer trying to deal with startup issues. So it's a combination of, the pressures building up in the system and how do you deal with deformations of the fuel. And we've been doing, FSI on that. So that's been a major capability of doing the multi-physics in, solid rocket motors. Also, how do we deal with the different materials for ablation, for reentries or inside rocket motors. So we've been adding capability. That's been added in the last version. Some simple forms of doing ablation modeling. So that's a key thing that we didn't have before, and it's user friendly. And when I say ablation modeling, it's the way the panel is set up. It turns it on, and it gives you options to use a simple model called Viel's law. Use that or surface reactions, depending on what kind of system you're working with. And it also turns on the moving mesh capabilities on that surfaces. So you can actually model that mesh deformation based on the ablation process going on in the system. So before we did it, it was all UDS and user had to do all the stuff. Now it's just push a button, set, pick the names that you're working with, set the model that you want to work. Hopefully you have your own, coefficients for the materials you're working with, because we don't, we just give defaults just to make sure it works, and then you go from there. But that's dealing with all these other capabilities that you run into with hypersonics. These are the key things as you have to deal. How do you deal with the heat? How do you deal with the ablation erosion problems? How do you model that? Because that becomes key. And it ends up being these coupled capabilities and dealing with mechanical side and the fluid side of it. So
I'm so glad you brought that up, because that was one of the painful parts of hypersonics in the past was modeling the ablation had all be done with user programmable features of one kind or another. And yeah, I'm glad to hear that that's come a long way. Good.
Yeah, and it's continuing too, because again, that was the first step, and there's going to be multiple steps, just adding more and more capabilities as we go. Same thing with all the other capabilities for again, different ablations, if it's external or internal, and how do you deal with it? What kind of reactions you're dealing with, what kind of particles you're dealing with, how do you deal with the chemistry, how do you deal with it? So that's all coming as we go, as we see the people have those needs, we're going to add those capabilities.
Good.
So,
Valerio, you have anything? Go ahead.
Yeah,
go ahead.
I wanted to say, because Bruce is hitting the nail on the head, especially in terms of multiphysics and developing these workflows that they're not only on the fluid side, but basically they extend to all the other technology areas that we have available. And I'll give a couple of examples, and these are all publicly available examples. One is the prediction of communication blackout effect. So that is something that from basically any reentry vehicle, and it was famous, it's always been famous, whether it was the shuttle or the Apollo capsules reentering. We have high speeds, and the air around the capsule ionizes, and basically that interferes with any antenna functioning properly. So there's no communication in and out of the reentry vehicle for, it depends, 5-10 minutes. And so what we have done, we actually create a workflow that goes from Fluent into our electromagnetic simulation tool, HFSS. And what that does is we take the ionization from the CFD solution, and we use that ionize the flow field to compute the conductivity of the air around the capsule. And then we compute the functioning, the performance of the antenna. So communication blackout is just a sub part of communication degradation. And we actually have been looking at validation of this approach, but to our knowledge, it's the only commercially available solution to compute these phenomena. In the other workflow, it is actually something similar, but that combines some of the more recent acquisitions by Ansys, primarily AGI, AGI family. So the SDK tool, and the whole application is actually relative to the detection and tracking of incoming hypersonic vehicles using infrared technology. And in a nutshell, is basically computing an initial release point of a hypersonic vehicle. It could be in space, it could be on Earth. And AGI Aviator starts computing the trajectory based on the aerodynamic coefficients that are being computed by the CFD. And by doing that, we are computing basically with a high level of accuracy the trajectory and the heating around this vehicle. And it could have a propulsive system, or it could just be re-entering. And that heating, it gets put into the AGI SDK, what is called the EOIR module, which is electro-optical infrared module. And the module is computing basically the infrared signature of this incoming hypersonic vehicle. And just to add the icing on the cake, I would say that starting from the high fidelity physics, so if you think about CFD, we're actually not using that to compute the whole trajectory. It would take too long. So we're actually extracting reduced order models out of that. And so that gives us almost instantaneous feedback with the trajectory calculation. So very, very advanced and very, technology that up to even just a couple of years ago, it was not available, and it is becoming available.
Yeah, just what Valerio said, with another model that we've been working on with another government entity, is they came to us wanting to do solid rocket motors. And then they said, well, can we do IR signatures on our solid rocket motors? And with the other product we have with Spisos, we're able to, we have working on a process that goes directly from Fluent into SPIOSOs, calculates the IR field, and then we post-process that IR signature. We can see the whole plume and see, and then also deal with the species of the plume and see what's there. So they can actually do, I figure out the full IR signature of their, of their motors. And it's pretty interesting how that works, and they're very excited with that capability.
That's very useful. Very, very useful. Yeah. Wow. Huh. Well, that's. I mean, it's good to see that it's not just in a bubble, right? You get that this tool is enabling RF simulation. It's enabling IR. Lots of two-letter acronym simulations. But I think it's a great example of when Ansys develops technology internally, because this is a great example of internal development, right? Of improvements to the hypersonic capability, and then making it work with acquired tools. I think it's something that really sets the Ansys team apart. And I know as a user and someone supporting and selling the software, we really appreciate it when development makes everything work together like this. It's fantastic.
I mean, from my previous experience with doing IR signatures, the process of running the case, post-processing the case, scripting the case, taking in together code. I mean, with the scripting and all the process was very intense and very customized for that specific case. Right. With the new models, with the capability that we have with the Ansys products, it simplifies it. It gets us away from the government codes that are sometimes not always well maintained, depending on what site they're on, and simplifies the process and makes it easier for them to keep the data and store the data too, so they can always refer to it or augment it when they need to do different data searches. So hopefully we can start building on that.
Very cool.
I would say, Eric, that workflows like the ones that we've been describing, they definitely keep people like Bruce and myself and a lot of our colleagues young, let's put it that way, and definitely on our toes, because it's a lot of innovation coming online, and definitely, you spend a career just looking at CFD, and then you realize, okay, how do we tie what we know how to do very well to everything else, and how do we make it more usable? And that definitely is challenging, but it's very exciting as well.
Yeah, we appreciate it. It's one of those things where in a meeting, it's like, we'll just hook them together, and then you start thinking about it, going, okay, this is going to be, you have to keep track of this. This is going to be difficult. Okay, so just to wind up, I think hopefully we've whetted people's appetites to learn more about this. What's the best way for them, besides just reaching out to their Ansys support provider, how to learn more about hypersonics, maybe even play with it? Are there some tutorials, some training classes on the Learning Hub? Where are we with that? And
Bruce, if you want, I can take it. And I think, starting from the Ansys website or the PADT website, that would be a really good starting point. There are many publications with validations. Those are out there. And the next step would be, we have actually a dedicated hypersonic training for CFD, and that would be a really good starting point. Because of the export control issues, it is not available widely, and so anybody would need to go through like their contact at Ansys, or drop an email, to the account manager or to technical support and we'll make it available.
Good point. I always forget that it's export controlled. So I don't always forget, but sometimes I forget that it's export controlled. And so it's not going to be in the Learning Hub. So definitely ask for that. And there's some cool videos as well on the Ansys YouTube page that I've been seeing, and hopefully some more as time goes by. I think that pretty much covers. I mean, we could talk about it for a long time, but I think we covered the big pieces. Anything else you guys want to add before we take off?
It's been a fun journey till now.
Very fun, very interesting. And thank you for giving us the opportunity to talk about hypersonics, which I think Bruce and I, we talk to each other about it every day.
It's true. And I think the other thing to point out is, you guys, it has been a fun journey, but you're not don't think you guys are halfway. I think that there's a lot more work that can be done to improve the tools and add more function, even not so much improve, but add more capability to the tools so people can model these extreme situations better and better as time goes by. So
it's going to keep us employed for a while.
That's exactly right. We really do appreciate it. Well, thanks for your time. I really, really do learn so much from these conversations, and hopefully in a couple of releases we'll have you guys back to learn what's new.
Thanks so much, Eric.
Thank you, guys. Stay safe out there. We'll talk to you soon.
Bye-bye.
Bye.
Bye.
So as we said, this is just a stop along a long journey. There's much more to come in this area for simulation. Ansys already has a fairly well integrated tool. It's one of the things I learned talking to other folks that are using, say, government codes or competitive codes. They're jumping around between 5 different tools and writing their own connections and all that stuff. It's fairly straightforward to do in Ansys, and I feel pretty comfortable after talking to some of those folks who are in the middle of this, that we are really, really on that curve and providing good solutions. If you're interested in this topic or are lucky enough to be working in this area, do stay tuned for more. We'll definitely keep you up to date as this capability progresses and becomes more capable. For today's commercial, I'm going to keep it short. If you are listening to the podcast, you probably have some Ansys software. You also should have learned from all of our podcasts that there's a lot of tools in the Ansys toolbox. You and your company can't benefit from the full power of simulation unless you have access to the right mix of tools. So reach out to your Ansys salesperson, and hopefully that's PADT. And that's Brian Bassier, Mike Borsum, Heather Dean, Howard Fine, Michael Quetko, Dan Christensen, Eric Coder, Jerry Garula, or Alan McNeil. I've never really mentioned all of them before on the podcast, but they're the sales professionals that help you find the right tool. They pair you with our engineers. They answer your questions. They're your go-to problem solvers. So set up some time to sit down with them and our engineers so you can understand all your options, and not just what software there is out there, but the new flexible ways that Ansys has given us to give you access to your different tools like Ansys Cloud and Elastic Licensing. So shoot us an email at info@padtinc.com or call us at 480-813-4884 or call your Ansys salesperson directly or email them. They'd love to talk to you and help explain all the great tools that we have in that Ansys toolbox. We're going to skip news and favorite blog posts and what the stock price is doing and all that stuff. Not a lot of big changes there, not a big to talk about. Instead, I really want to talk about the Ansys Technical Conference coming up, which is Level Up 2.0. So let's take a listen and learn all about it. I want to welcome everybody today for a brief chat here. Today we've got with us Marissa Melchior, and Marissa, thank you for joining us. Why don't you? We're going to talk about the upcoming Level Up 2.0 conference, but first, I think our listeners who don't know you would like to know who you are and what you do at Ansys.
Awesome. Thanks so much, Eric. Well, my name is Marissa Melchior. I am a manager of product marketing here at Ansys. I cover the structures business unit as well as the 3D design business unit. Super excited to be here and talk about Level Up 2.0.
Great. Well, and our favorite products here on the podcast. So we're very glad to have you out there evangelizing on our behalf. So we appreciate that. So Level Up 2.0 is coming up on October 20th of this year. It's a virtual engineering simulation conference. So why don't you help our listeners understand what it is and what it's all about?
Yeah, absolutely. So Level Up 2.0 is an extension of our first virtual free conference in the structures business unit. It was great success last year, so we're doing it again this year, but we're really expanding the scope, a lot more tracks and a lot more products, a lot more sessions, a lot more customer stories. So really this free virtual conference of Level Up 2.0, bigger and better than ever, leveling up our sessions, more products, innovative solutions, new opportunities. And Eric, it's really a conference for every engineer, no matter where they're at in their simulation journey. If they're just getting started with simulation and wondering where to start, or if they're more advanced user and have been using, for example, Ansys Mechanical or LS-DYNA for decades. There's really something for everyone at Level Up 2.0.
That's kind of what I noticed when I was looking at the tracks and the speakers, is that this really appeals to, your diehard APDL fans all the way up through, I'm a design engineer and I want to do more simulation as part of my product development process. And there is something here for everybody. So I really dig that, and makes it value added. So you mentioned that this is the 2.0, and it is free. I think it's important that our listeners know that.
Yep.
It's virtual. One question I had is, will it be recorded, or do they need to attend live to get all the content?
Yeah, we are telling people to attend live because we have some really, really great featured speakers that are doing live sessions. You're going to hear from NASA, Off-World, a startup that's putting robots on different planets. You're going to hear from Boeing. We have this really cool live session at the closing of the virtual event called Taking Your Simulation to the Next Level with Digital Mission Engineering. Really excited to talk about this with our integration of AGI to the Ansys portfolio. So really talking about, the whole digital mission engineering and how simulation plays an important part of that.
Yeah, that to me is worth the price of admission in and of itself, because we've been taking a really closer look at AGI and what it can do, and more importantly, how it integrates with and is going to integrate with other Ansys products in the future, and it's pretty exciting stuff. It's definitely there's a lot in here to go to, but that's going to be definitely on my list to check out. So you mentioned that it is a few products. So which Ansys products are going to be covered? Are we going to be just structural? Is there fluids? What's in there?
Yeah, great question. So last year it was just Ansys Mechanical and only 12 sessions. And we really expanded the scope to not only include products from the structures business unit, but also fluids and a little bit of acoustics as well. So we have, Ansys Mechanical, our bread and butter. We have a full track on that. We have LS Dyna as well. So really cool sessions on that with drop tests, tips and tricks with Ansys LS Dyna, understanding contacts. Then we do have a full track on fluid. So super excited about a lot of these sessions talking about how to generate a high quality mesh using Ansys Fluent. We definitely are going to go into advanced manufacturing and design. This is where we're going to talk about additive manufacturing. We have some really cool stories about replacement parts on demand, leveraging additive manufacturing for lightweighting. Really, really cool, innovative sessions there. You're going to hear from Siemens, Prankel, and C-Space, which is a really, really cool startup about rocket engines. Cool. Yeah, and then just a few more. Yeah. We have acoustics and NVH. So we're going to be talking about our product, Ansys VR Experience Sound, and its connection to Ansys Mechanical, LS Dyna. There's a really, really cool session talking about the studying of acoustics behavior of an automotive seatbelt retractor. So how the sound affects the seatbelt, right? That little click that we hear is so important to make sure the seatbelt is working. We have electronics reliability, a spotlight solution set on that. So really talking about thermal conduction, trace modeling with layered elements. And then we're going to have upfront simulation, which talks about our Ansys Discovery products, as well as advanced geometry preparation, and really going into the idea of bringing simulation upfront into the simulation journey and design engineers.
That's great, very comprehensive, and boy, once again, it's going to be difficult to decide which track to go to, which to me is always a good sign of a good conference, is trying to pick which ones to go to. So that's fantastic, and it goes from 10 p.m. all right, Eastern time to 10 a.m. Eastern time, and how long about is it going to last?
It should wrap up around 3 p.m. Eastern time. Okay. So what's really cool, and we got really great feedback last year about the sessions are about 30 minutes long. Okay. So they're short, sweet. They're definitely informative, but it allows you to jam pack a lot into your agenda. So if you register today, about a week before the actual live session, you can actually go build your agenda, which enables people to build their agenda, get an idea of what the agenda is going to look like with abstract. So really opening up the platform for attendees to kind of take a look around at the platform.
Yeah, and I'm looking at the website right now, and it does have the agenda is up. You can see when the sessions are and who's giving them. And one key thing that's coming through is, boy, I'm going to just enjoy because some of my favorite people at Ansys are presenting. So
Yeah.
you don't always get a chance, especially in the day of COVID, to interact with these technical experts at Ansys. And this is a great chance to hear them speak and to get to know them a little bit better. So I see that Kurt Chan's doing a ton, that Bill Holmes is speaking. I mean, I'm just scrolling down and pulling out names of people that we've worked with over the years, and some new names. So some new people that we need to get to know better. So this is a great opportunity to get to know the folks behind the logo, as we like to say, and that make Ansys such a powerful tool and help users use it. So this is great. I'm excited. The sign up it's actually at ansys.com/events/level-up. But nobody types in the URL. We'll put it in the meeting notes, as well as I just searched for Ansys Level Up 2.0, and it came right up in the search. So
yeah, and to make it even more simpler, you can just do ansys.com/level up.
Okay.
That's a little shorter version, easier to type in the URL. You could always give us a follow on Ansys Structures page on LinkedIn. We're always posting about like up and coming events. We're doing a lot of promotion for Level Up. So if you give us a follow, you'll definitely be able to access the registration page easily. Some other just really key points about this event is we have a session on PyAnsys, which talks about automation and scripting with Python. So that's something really cool and upcoming. Yep. And Eric, just like you said, it's really, really great opportunity to talk to Ansys people directly. That is something that we got feedback last year, just the energy and the excitement that all the presenters really bring. And it really shows the enthusiasm that we have for our products, which is really great to talk to. So you will have the ability to talk to the presenters in their sessions during the time of the live event from 10 a.m. Eastern time to about 3 p.m. Eastern time. So really looking forward to hearing from you all and attending our event.
I'm looking forward to it. The interactive part is sometimes the best, and I love this platform. This virtual. I think we're getting it down. I think it's working, and it's a great way to get this input. And I'm actually glad you guys are doing it live. I think we all sign up for things thinking we're going to listen to the recording and we don't. So I'm glad, and the interactive part as well is well worth it. So set aside go to the website, register, and then put it on your calendar so nobody schedules any meetings over this. And get some coffee, settle down, get your headphones on, and enjoy a great day. We'll be there. PADT folks will be listening in, so we hope to run into you in some of the discussions. Anything else you want to add before we move on?
I don't think so. Again, thanks so much for the time, Eric, and the opportunity to talk about Level Up. It's really about taking your simulations to the next level. So I hope to see you all there, and we're getting ready to level up.
Yep, exactly. I can't wait for it. I really appreciate you guys taking the time to put all this together. It does make a difference for us out here in user land. So appreciate it. And we'll see you. There's a little clock at the bottom. In 27 days, 23 hours, 45 minutes.
Yep, we're waiting for it.
All right. Talk to you soon.
Thanks, Eric. Bye.
Bye.
Okay, hopefully you're already registered, and if you're not, that was enough to get you interested. It is a good event. It is live but virtual, and so you can't trick yourself into thinking you're going to listen to it later and not. So please do go register. That's at www.ansys.com/levelup. We'll take you right there, and I hope to see you guys online. Like I said, we're going to skip most of the rest of the podcast and go straight to events. And boy, do we have a lot in the world of PADT. It's many organizations basically put all their events in October that usually take place throughout the year. So it's really piled in. It's usually a busy month for us anyway. So the first thing tomorrow on the 4th is AZ Bio Awards. And we're not doing the actual awards that we normally do. The AZ Bio is the organization for technology companies around biotechnology in the state of Arizona. And PADT has been a sponsor for many, many years and an award recipient now and then. Many of our customers are up for or winning awards this year. And instead of having it live, we're we're going to do it as a TV show again. So it's actually going to be, I think, on Channel 15 here in Arizona. Do check that out. The AZ Bio Awards, just search for it and you can get all the information on how to watch it online or how to watch it on TV live tomorrow night. Then in the morning of the 6th, which I believe, I got to check my calendar because I'm getting all confused by all these different things. Yeah, the 6th is Wednesday. We're headed down to Tucson for the 2021 Southern Arizona Tech and Business Expo. So we're spreading out across the Tucson Convention Center from noon to 6. It's a fantastic event. It's my favorite event in Tucson every year. One of my favorite events in Tucson. I have a couple favorite events in Tucson, but it's one of my favorite events in Tucson. And it's a great chance to catch up with everybody and visit booths. There's some awards that are going out. There's some great keynote speakers. So if you're in the Tucson area or Southern Arizona area or in the rest of Arizona and want to learn more about Tucson and tech, head on down to that event. We will be doing also a webinar on the 6th, which is Wednesday, Space Claim Meshing and Geometry Updates in Ansys 2021 R2. That's probably more applicable to those of you who are not in Arizona. So please do check that out. Lots of Space Claim is just growing and improving like crazy. So big fan, and it's a great chance for you to learn more about what's going on in Space Claim, which is an important tool that you should be using if you're not. Then on the 7th, Thursday, is Venture Madness and about 3 other events on top of that. So we piled all our startup type of things into one full day event on the 7th, which is going to be at a new building at the University of Arizona Health Science Education Building in downtown Phoenix. So there's some events the night before, there's events that night, but the big event is the Venture Madness General Session, where all the best technology startups in Arizona show what they got. And we will also be doing. We're going to be at that event and hope to see some of you there. I also want to point out the following week on the 12th, the Arizona Tech Business Virtual Networking is back. These are things that if you've been listening to podcasts, you know we were doing during the pandemic when most people were home. Well, even with most people home, we found that back at work, we found that the virtual events worked really well. So again, very Arizona oriented. I'm sorry for those of you not in Arizona, but we're going to be doing that tech virtual networking again on the 12th. So do check that out on our events page at PADT. And then some other events to mention in that week are the Governor's Celebration of Innovation, which is the big tech awards show here in the state. I will be giving out the Chairman's Award this year as the chairman of the Tech Council Board of Directors, and I'm really excited. And we've had the actual, I don't want to give it away too much, but it's a pretty cool event, and we're really looking forward to that as well. We are also traveling around the southwestern U.S. with Stratasys and their mobile truck. So if you want to see the new machines that Stratasys has out, the new materials that Stratasys has out, we've got a bunch of stops for you. The first one's going to be in Denver on the 14th. And then we're moving up to Centennial, which is the north side of town, on the 15th. On the 15th, the next day on the 15th. Then we're going to be in Los Alamos, New Mexico on the 19th and Albuquerque on the 20th. And we're finishing up for PADT's big open house, which is going to be it's going to be an open parking lot, actually, on the 27th, our Nerdtoberfest 2021. It'll be at that event as well, the mobile truck. And then we'll be headed down to Tucson the next day, 2 days later on the 29th, to show off what Stratasys has there. So like I said, a very busy October, mostly Arizona events. Apologize for that for those of you at other locations. But if you are in Arizona, please do stop by and see us. If you're in one of those other states that we mentioned, come by, sign up for the Stratasys mobile truck. All of this stuff is available at padtinc.com/events, including registration links. So do check those out. And that's it for today's podcast. Lots of good information about events and hypersonics, and really loved it. I want to thank you as always for listening in. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in to learn more about what's going on in the world of PADT. And also, please do let your friends and coworkers know about the podcast and subscribe. And you should subscribe so that our numbers continue to grow. So, and as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 98. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.